Data is going to be one of, if not the most important part of your web app. For that reason, it's important for us to understand how to set up our data collections correctly, or at least what things should be going through our mind, what points should we be considering when we are setting up our data collections. In order to understand this, I want to do a few thought experiments. In each thought experiment, I will present you with a type or types of data for an imaginary application, and I want you to think about how you would organize this data inside of your CMS. So what fields would you have in what collections, and what relationships might there be between the different collections if you choose to have more than one? So for the first thought experiment, let's organize the data for a quiz web app. So you are going to have a quiz or multiple quizzes, and each one of these quizzes is going to have some questions and answers to these questions. You can think of other supporting fields that you might want to add for, imagination's sake, but those are the key data pieces that we want to try and organize. So at this point, I recommend you pause for a second and just try and think. You could take out a pen and paper or type something up in a Word doc or a Notion or something like that. How would you organize the data for this kind of application? What collections would you have? What fields would you have? And what would the relationships be between all of these? Hopefully you took a moment to try and brainstorm this yourself. And as I go through my thought process, keep in mind that with things like this, there isn't only one correct answer. I'm going to present a certain approach and explain the reasoning behind it. And it could be that it is the right approach for some use cases, and there might be other use cases that other approaches might be better. So first of all, let's discuss what some people might think initially before being very familiar with best practices for organizing a data collection or data collections. So let's assume that we have for now one quiz which has multiple questions, and each question may have multiple answers. So one approach that people sometimes take initially is to build a flat database. So that means that we would have essentially one database. Okay, this will be our database. And this will be, let's say, our quiz collection. And if we had multiple quizzes on the website, we might build maybe several collections for one for each quiz. Next, within this quiz collection, we would have all of the questions with regard to that quiz. So for example, we would have, let me just open up a note here. So we would have, let's say, question 1, and then we'd have another field, then we'd have another item. Okay, that would be for question 2 and question 3 and question 4. Okay, so essentially each item over here is going to be a question. So question 1, and then we have question 2, etc. And each one of these items would have essentially multiple fields. So for example, one question might have several fields. So it would have the actual question, and then it would have perhaps the options for the answer. So it would have answer 1 and answer 2. And here I'm assuming that we have, a multiple answer question, so a multiple selection, multiple choice, that's the word I was looking for, a multiple choice question. And lastly, we might have, let's say, correct answer. Okay, so this might be one approach to the data structure for our quiz web app. So we have multiple collections, one collection for each quiz. Inside of each collection, we'd have multiple items. Each item would represent a question. And we would have for each item several fields. One would be the actual question. Then we'd have several answers. The correct answer, maybe something to indicate the order that these questions should be in. This structure presents us with several issues. So one issue is that we are not very scalable in terms of the relationship between questions and answers. It means that, for example, if we wanted to create an answer bank and have several questions be related to several answers, we wouldn't be able to do so, or doing so would create a lot of multiple entries of data. We're also limited in terms of how many answers we can have for each question. Obviously, we can always add more fields, so we could have, field answer 1, answer 2, 3, 4, 5, 6, etc. But essentially, when we're initially building our collection, we would build it up to a certain limit. For example, let's say 4 possible answers. And then if later on we wanted to add an additional answer for each question, or have questions that have 3 answers versus questions with 6 answers, we would hit a certain wall. So we're not being very flexible in terms of the relationship between questions and answers. Another issue of scalability that we have here is that our quizzes are each a unique collection. That means every time that we want to add a new quiz to our CMS, we have to create a whole new collection with the same fields. And then every time, for example, we wanted to change the structure of a quiz or have any metadata with regard to our quiz, it would essentially require us to update all of our collections. So we're hitting walls there in 2 directions. Now, taking those considerations into account, if your answer looked something like the one I just presented, please take a moment to consider the scaling issues and try and create a new approach where the relationships create a more scalable data system. So take a moment, you can pause here, and let's meet on the other end to discuss a slightly more scalable approach to this issue. Welcome back. I hope you took a moment to think about it. And now let's go ahead and brainstorm together about how we can build a more scalable system. So for this new approach, I'm going to be adding multiple databases, each one containing a different data type. So let's start off with one database. This database will be our overall quizzes database. So this is a database that will aggregate all of our quizzes. We'll discuss in a moment what exact fields it will have and what relationships it will have. In addition to a quizzes database, we will also have a questions database. Okay, database here is the equivalent of a CMS collection. So here we're going to have questions, and we're going to have another third database, which is going to have answers. Okay, so here, with regard to each one of these collections, let's think about what its relationship needs to be to the other ones. So in our quizzes collection, we are going to have multiple individual quizzes. So this is going to be, let's say, for example, quiz 1, and then we'll have quiz 2, etc. Okay, and for each one of these quizzes, we can have multiple fields. So we can have a field that will be the title of the quiz. We can have a field that will be how challenging the quiz is, let's say from 1 to 10, etc. So here we already expose one advantage where we have metadata about each quiz that we can store alongside the questions. Inside of our questions collection, we are going to have a lot of different questions. So question 1, for example, and then we're going to have question 2. And the relationship between these two data collections is a one-to-many or many-to-many relationship. So we could have, for example, a relationship here where question 1 and question 2 are both part of quiz 1, and we acknowledge that relationship inside of the quizzes collection by linking to the items in another collection. And we'll talk about different ways that we can do that practically, but for now we're just talking conceptually. We could also have a many-to relationship here. So For example, question 1 could be part of both quiz 1 and quiz 2. And then we might have a question 3 that's part of quiz 2 but not part of quiz 1. Okay, so we already are creating a much more flexible system where we can have a bank of questions and decide what the relationship is between those questions and those quizzes so that a quiz can have, for example, as many questions as you might want. Next, we have our answers collection. Here as well, we can establish a one-to-many or possibly even a many-to-many relationship, even though that's less likely in the case of answers. But essentially, we can have a document here for, answer 1, and we'd have answer 2, and we'd establish the relationship between this question and answer 1 and this question and answer 2, for example. Okay, so I won't go ahead and there we go. Answer 2. I got them connected. So here we're creating a much more scalable system where changing the documents in one of the collections doesn't directly affect one of the other collections, and we can determine a one-to-many or many-to-many relationship without having to decide how many answers, for example, to be in a question, how many questions there would be in a quiz, and we can store relevant metadata about each one of these things. So we can have metadata. When I say metadata, I mean other data surrounding, for example, an answer beyond just the answer. Okay, like we can collect data, how many times people pick that answer in general or something along those lines. I'm really just throwing out examples here just to try and highlight the advantages of building the system in a more scalable approach like this. Obviously, one point which I haven't mentioned yet is the fact that our website will only ever need 3 collections as opposed to an undetermined amount of collections if we built a new collection for every single quiz.